Hi there. Sorry I couldn't be there with you guys today. So because I'm out today, I'm going to have to go through this lesson with you via this video. So as you guys know, we finished skills 2 through 4 on Tuesday, and then now we are going to move forward to skill 5. Skill 5 is working with what we call rational exponents. So before we actually get into that, I want us to just review like rules of exponents from Algebra 1, so we at least have a good idea of how exponents in general work before we add in a new property. So here you'll notice on the note guide that there are these review properties, and we're going to just kind of fill in these blanks. So the first one is the multiplication property, which is when you're multiplying same bases. So you'll notice here I have like an x to a power times another x to a power. When that's the case, we just add the powers. So the property says to do x raised to the power of m plus n. So an example of that would be like, suppose I was doing x to the 4th and then times x to the 7th. According to this property, that would mean I have x to the power of 11. I would add the powers. Then if I'm dividing same bases, so again here you can see I have bases of x, they're being raised to different powers. This property says to subtract the powers. So what I would do here, I'll use a similar example as the last one. So suppose I had x to the 7th and I was dividing that by x to the 4th. According to this property, I would subtract these powers. So then this would end up equaling x to the 3rd. We then have the power property of exponents, which says you have a base being raised to one power and then all of that being raised to another power. The power property tells us to multiply them together. So an example of that would be if I had x to the 4th and then I was raising all of that to the 7th power. According to this property, that would mean I have a full on 28 factors of x to the power of 28. The 0 property says if you take a base and you raise it to the power of 0, we just say that that value equals 1. And that's true for any base. So I could even have something like negative 187 and raise that to the power of 0, and it just goes back down to 1 again. Then we have the negative exponent property, which is when you have a base raised to a negative power, the property tells us to take the reciprocal of that base to the positive version of that power. So as an example, if I had like x to the power of negative 7, what I would do is put that underneath 1 over, and then x to the power of positive 7. So that's just a quick little review of how these exponent rules work in general. The one we're going to take a little bit of time right now to think about is what happens if you're raising your variable base, or any base actually, if you're raising a base to a power that's in the form of a fraction. So that's why we use this word rational to refer to the ratio. So I'm going to step away from the note guide for just a little bit to discuss the meaning of a rational exponent in general. And maybe I'll refer to this as a fractional exponent, because what I'm going to first do is just relate rational exponents to multiplying by fractions. So what I want you to first think about is the meaning of just multiplication in general. Multiplication, for example, like let's say you had 3 times 4. That would just indicate that you're adding 3 to itself 4 times. So I want you to think of multiplication as repeated addition. And the number you're multiplying by is just telling you how many times to add the 3 in this case. So if I do 3 plus 3 plus 3 4 times, I end up with 12. So we know that 3 times 4 is 12. So then I want you to think of what exponents represent. So an exponent, for example, if I did 3 and raised it to the power of 4, that would mean that I'm multiplying 3 to itself 4 times. So an exponent is referring to repeated multiplication. So if I multiply 3 to itself 4 times 3 is 9, times 3 is 27, times another 3 is 81, then I get this result, which equals 81. So now what I want us to think about is what happens if I then take this result, this product, if you will, when I did 3 times 4, and I multiply it by a fraction, 1/4. So suppose I am doing 1/4 times 12. Well, we think of that as division, right? 1/4 times 12 is the same thing as 12 divided by 4. And what's happening here is we're saying, well, I added 3 to itself 4 times. So when I'm taking 1/4 of 12, I'm taking one of those 4 numbers I added, one of the 4 terms, if you will, that make 12. Since 3 is the number added to itself 4 times that makes 12, then 1/4 of 12 is just 3, which is basically division. So then the question is, what would happen if I took the result of repeated multiplication? So if I took this 81 and I said, okay, 81, what if I raise that to the power of 1/4? Well, that is actually similar in meaning as over here when I just multiplied 12 by 1/4. Basically, since I was multiplying here, I just had to consider what number adds to itself 4 times to be 12, and then that was 3. Essentially, I was dividing 12 divided by 4. So here, since this is exponent notation, I'm thinking of repeated multiplication, and so this would be telling me to look for 1 out of the 4 factors. So now we're looking at factors, not terms. 1 out of the 4 factors that make up 81. And since 3 is the number that multiplies to itself 4 times to be 81, then 3 would be 1 out of those 4 factors that make up 81. So in a sense, raising to a fractional power is like rooting. It's like taking the root, the 4th root of 81, because it's asking you, what number times itself 4 times is 81? Oh, that's 3. So this is essentially the meaning of this fraction is to take the 4th root of 81. So the official property for rational exponents looks something like this. First, you have this idea like suppose you have x and it's being raised to a 1/n power. So this is what we would refer to as an nth root. And we understand that to be a radical sign with an index of n, or an nth root. Kind of like what we were just doing a second ago when we did 81 to the 1/4 power, and that was 3. We were thinking of that as a 4th root of 81. But the other thing we need to consider is when I have a fractional power that doesn't have a 1 in the numerator. So that would, by definition, that would mean I have still an index of n, but it would also mean that I'm also raising this x to the power of m. And you can do that in any order. You can either do the nth root first and then raise that to the power of m, or you can raise the inside to the power of m and then take the nth root. But essentially, the numerator is the power, and then the denominator is the root. So now I want us to go back to that 81 example again. Like, let's go back to that 81. We know that 3 raised to the 4th power is 81 because 3 times 3 times 3 is 81. So if I were to take 81 and raise that to the 3/4 power, I want you to think about what that's really saying. That's saying to take 3 of the 4 factors that make up 81. So this is saying, you know that 3 times itself 4 times is 81, because we have to 4th root it, right? This is saying to take 3 of those. So the result of that would be 27. Because since it's repeated multiplication, we're talking about once I get the 3 out of the 4 factors, that's 3 times 3 times 3, I have to put them together with multiplication. Suppose also that I had 81 to the 2/4 power. Well, that's basically saying to take 2 of the 4 factors that make up 81. So again, we know that the 4 factors that make up 81 is 3 times itself 4 times. So 2 of those 3's would be 9. And that's because we had 81 to the 2/4. 2/4 reduces to 1/2. And so that's like saying take a square root, if you will. So if I were to think of what 81 to the 1/2 is, well, I'd have to think about what times itself 2 times is 81. And that would be 9 times 9. And if this is saying take 1 out of those 2 factors, in other words, the square root of 81, well, that would be 9. So I can think of that as 81 to the 2/4 or 81 to the 1/2. It both turns out to be the same. And then again, if you have like 81 to the 4/4, well, that's just 81 to the first power, or that's all 4 factors that multiply to 81, which is why that's just 81. So when we're working with bases that are numbers and they're raised to rational powers, I tend to think of it this way. First, you consider what the 4th root is, like what times itself 4 times is 81. Then the numerator would tell you how many of those factors to take. The other way to think about this, though, suppose you had 81 to the 3/4 and you wanted to use the property, you could either think of it this way: a 4th root of 81 cubed, which is, in my opinion, the harder way to think about that. Or you could think about that as the 4th root of 81, like determine that, and then that being cubed. That's kind of what we were doing here originally when we thought of 81 to the 3/4 as 3 of the 4 factors that make up 81. We were basically 4th rooting 81 first and going, okay, the 4th root of 81 is 3, and then I need 3 of those. 3 times 3 times 3 is 27. In my opinion, this is the easier way to evaluate a number base raised to a rational power. This is also correct, but obviously, like without a calculator, it would be really hard to raise 81 to the 3rd power first and then 4th root. This is a much easier way to do it when you don't have a calculator. So we would find the 4th root of 81, which is 3, and then we would raise that to the 3rd power to get 27. So that's how like the property can be used to evaluate these rational exponents. Okay, so let's add that now to the top of your note guide. Right here, if you have x raised to the power of m over n, that's going to become the nth root of x to the power of m on the inside of the radical, or the nth root of x, whatever that is, and then raised to the mth power. So in other words, the numerator of the rational exponent is the power, and the denominator of the rational exponent is the root. An example of that would be the one we just did, where if you take 81 and raise it to the 3/4 power, you're basically 4th rooting 81 and then cubing the result. So figuring out what number times itself 4 times is 81, which is 3, and then taking 3 of those 3's to get 27. So 81 to the 3/4 power is 27. And it makes sense that the result is less than 81 because the power I'm raising 81 to is less than 1. So let's just do a few more examples to get an idea. And I'll do this the way that I like to think about it, but you're also welcome to just use the new property we just learned. So when I do stuff like this, I like to think about this as 3 out of the 4 factors that make up 16. 16 is 2 times 2 times 2 times 2, and I'd be taking 3 of those. So that would be 8. This is saying to take 1 out of the 2 factors that make up 49. The 2 factors that make up 49 are 7 and 7. This is saying to take 1 of them. And then that expression there is telling us to multiply the result. So this is how I would do this. I would take 3 2's to get 8, 1 7 to get 7, multiply them together to get 56. Another thing we can do now that we understand that these are just exponents, and we can combine them with other exponent properties. So here you might notice that I have same bases, 13 and 13. So according to the multiplication property, I would add the powers. So this is telling me I have 3 halves factors of 13 times another half factor of 13. So altogether I'd have 13 to the 4 halves power, which is basically 13 squared, which is 169. So that's just kind of combining just rules of exponents together with rational exponents. This one here is using our rational exponent and negative exponent properties together, because you can use them together. So since the exponent's negative, I would do 1 over 64 to the positive 1/2 power, 64 to the 1/2 power is saying to take one of the two factors that make up 64. So 64 is 8 times 8. So that would just be one of those two 8s. So then this simplifies to simply 1 over 8. Okay, so these would be examples of evaluating. On your note guide, you'll notice there's one section where you're supposed to copy down, and you can pick one of these to copy onto the note guide. Now we'll do another example where we are rewriting into radical form. So that'll be one of the type of questions you're asked, is you're given rational exponent form and then just simply asked to convert. So first of all, we notice in this example that there's a negative exponent. So I have to do 1 over d to the positive 3/2. And then the next thing I want to do is convert that into radical form. So this would be a square root of d cubed according to the radical exponent property. The 3 becomes the power, and then the 2 becomes the index. And then now what you might notice is we now have an expression that is no longer rational in the denominator. So we would need to rationalize our denominator. So I'd have to multiply top and bottom by the square root of 1 more d so that I could have 4 d's in the denominator. So then I get the square root of d all over the square root of d to the 4th, which is just d squared. And then now I have converted it into radical form and also rationalized the denominator. Another example of converting to radical form is, so notice that in this case, only the y is raised to the power of 4/5, not the 2, the negative 2. So the negative 2 would stay outside of the radical. The 5 would be the index, because that's the root. So it'd be an index of 5 or a 5th root, and then I'd have a y to the 4th inside the radical. And then this would be the final answer, because there's not enough y's to take out, so I would just leave it like that. The main point of this example was just to show you that only the things being raised to the powers are what end up in the radicals. Any other items would just be left outside. Okay, so I want you to choose one of those examples to copy down on your note guide where it says pick one that asks you to rewrite in radical form. Okay, and then you also will need to pick one that asks you to rewrite into exponent form. And so when we rewrite into exponent form, we take a look at the powers that the variables are being raised to under the radical, and then we also consider what the index of the radical is. And when we write it as like a base that's raised to the power divided by the index. They're connected by multiplication, so then that's being multiplied to this base b, that's being raised to the power of 3, and then that's being divided by 2. So the exponent form would be a to the 1/2 times b to the 3/2. So it's just using this property, but in reverse. This property is just basically saying that the power goes into the numerator and that the index goes into the denominator. So we can use this forward and backward. And then here, same idea. My base is w. It's being raised to the 2nd power, so that would go in the numerator. And then that's being cube rooted, so that means that the power of 2 is being divided by 3. And so there you go. The power is the numerator and the root is the denominator. So on your note guide, choose one of those to copy down into the box. Let's see, I think it says it here. Oh, wait, no. Let's see, there's 2 more, sorry. So then now you need to write, so now there's 2 examples of where you would need to write expressions in what we call simplest form. So here, what I notice is that I don't have a matching base, but I do have a matching index. And that is what will allow me to go ahead and multiply the 12 with the 8, is because they're both under a cube root. And so what I'm going to do is I'm going to think about the 12, that's 2 times 2 times 3, and then the 8 is 2 times 2 times 2. So, okay, yeah, I can't really take anything out from the 12, but I can take the 2 out. I can cube root the 8, essentially. So I'll take the 2 out of the cube root, and then inside the cube root, I'll just leave a 12. Or you could write that as 2, and then I could just leave it as 12 to the 1/3 power. So basically, you could just evaluate this one. This was unable to be simplified, so we just leave it. 2 times 12 to the 1/3, or 2 times cube root of 12. Either way, depending on which form you're asked to put it in, whether it's radical or exponent. For this one here, I notice that the bases are all the same, and I'm multiplying them together, so that will allow me to add the powers together, which could help simplify this a little bit. So I end up with 2 plus 4 plus 1, so that's 7/5. So if you're asked to leave your answer in exponent form, that would be your answer. Or if you're asked to put it in exponent form, we would write that as a 5th root of x to the 7th, depending on what form you're asked to put your answer in. Okay, so on your note guide, you have to write down an example where you were asked to evaluate. That was like the first 2 things we did. Then the second 2 things we did, you want to show an example of going from exponent form to radical form. And then you want to show example of going from radical form to exponent form. And then show one of the examples of just simplifying. So just pick one of each set to copy down and put onto your note guide. You can pause the video and do that now, or you can wait till the end. Okay, so before I go on to the last set of examples, I do need to show you one other thing we can do now that we know about rational exponents. We now have the ability to simplify radicals by reducing the index. So here's an example where if I was doing this just according to simplifying radicals, we would go, oh, okay, I have a 6th root, but I only have 3 2's. So I'll just write 3 factors of 2. So we might say, oh, I can't simplify. I just have to leave my answer as a 6th root of 8, because in radical form, that's as simple as it gets. But now that we know about rational exponents, what we notice is that, okay, yeah, I only have 3 2's. But the number of factors of 2 that I have, which is 3, can be reduced with the index of 6. So we can, for a moment, we can say, oh, this is like saying 2 is being cubed and then 6th rooted, or raised to the power of 3 over 6, right? We had a power of 3, and then we had a root of 6. So then that's like saying, oh, that's the same thing as 2 to the 1/2 power, because the 3 over 6 is the same as a 1 over 2. So actually, that's just the square root of 2. So now that we have skill 5, if ever you come across something like this, a 6th root of 8, we would want you to be able to get that all the way down to a square root of 2. Now, if you think about it, that makes sense, right? If I am trying to find like what number times itself 6 times is equal to 8, well, that would be the square root of 2. Because if I did the square root of 2 times 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 the square root of 2, right? Square root of 2 6 times. Every time there's a pair, I get a 2. And so I end up essentially multiplying 2 to itself 3 times. So rad 2 is the number, the simplest form of the number that multiplies to itself 6 times to equal 8. So it really is the 6th root of 8. But this is now something at our disposal now that we can utilize rational exponents. We can reduce powers with roots. Okay, so for our last set of examples, we're going to be looking at how we can utilize rational exponents to further simplify radical expressions that we weren't able to simplify before. Okay, so this is another example like the one we just did. So we might say, okay, 64, I can break into 8 and 8, and then that could go into, that could go into 4 and 2, which goes into 2 and 2, and then this 8 can break into 4 and 2, and then that can go into 2 and 2. And so I actually have 6 factors of 2, right? 2 to the 6th power. So what I can do is think of that as this is 2 raised to the power of 6/4, if you will. And then that can reduce to 2 to the 3/2 power. So then I can write this 4th root of 2 to the 6th is the same thing as the square root of 2 cubed. And the square root of 2 cubed, well, that's the square root of 2 times 2 times 2. So I can take 1 2 out and leave 1 2 inside. So 2 times the square root of 2, that is the 4th root of 64. Another way you could have thought about this one is you could have said, well, I have 6 2's, right? And they're underneath a 4th root. So I could take out 1 2, right? And then that would be the 2 that comes out. And then I'd have the 4th root of 2 squared left over. or the 4th root of 4, if you will. So then we could say, okay, well, that's 2 times 2 to the power of 2 over 4. And then we could have reduced the 2 over 4. That can become a 1/2. And then from there, we could recognize, oh, that's just 2 that we took out from before. And then the 4th root of 4, if you will, or the 4th root of 2 squared, well, that's just the square root of 2. And so we can end up with the same answer that way as well. With this example, you might say, well, I don't have any way to reduce power with index, and that would be correct. What we're going to try to do here is see if we can actually multiply these things together. See, before we wouldn't be able to multiply these 10s together because the indexes don't match. But now what I can do is rewrite these using rational exponents. This is a 6th root of 10, or a 1/6 power of 10. This is a 3rd root of 10, or a 1/3 power of 10. I can utilize rule of exponents to go ahead and add these powers. Because when you're multiplying same bases, which is what we have here, you're essentially adding the powers. Of course, I do need to get a common denominator, so I need to turn my 1/3 into a 2/6. But then what I notice is I'd have 1/6 plus 2/6, so that's 10 to the 3/6, or that's the same thing as 10 to the 1/2, and that's the same thing as the square root of 10. So how do you like that? The 6th root of 10 times the cube root of 10, that ends up equaling just the square root of 10. And we were able to actually combine these through multiplication, through the addition of their rational exponents, to get to this final answer. Okay, so this one here, we're just going to try to evaluate if possible. So I'm evaluating a negative base, which is okay because my root, if you will, is odd, right? It's an odd root. So we're allowed to take odd roots of negatives. So I would think of this as a 3rd root of negative 64. I always do my roots first when I have to evaluate numerical bases, and then raise that to the 5th power. So the cube root of 64 is negative 4, because 4 times, or actually negative 4 times negative 4 times negative 4, right, that equals negative 64. So the cube root of negative 64 is negative 4, but then I need to raise that to the 5th power, because this is saying the 5/3 of negative 64. So it's going to have to be bigger than negative 64. So really what's happening is I have my negative 64, right, from the first 3 factors, but then I need to multiply 2 more factors. So I'd have to do 64 times 16. So let's see, that would be 6 times 4, 24, 6 times 6, 36 plus 2, 38, add the 0, and then you got 1 times 4, and then 1 times 6. So we'd have 4, 12, and then 10. So that would end up being, and there would be an odd number of negatives, right? So these first 2 would become positive, the second 2 would become positive, and then you got that 5th one making the whole thing negative. So this would end up equaling negative 1,024. But I do think it's easier to go about it this way instead of trying to raise 64 to the 5th power first and then cube rooting. I highly, highly recommend cube root first and then raise to the power. So then in this one, because the power is written as a decimal, this can be really intimidating. So I would first recommend just rewriting it as a fraction, right? So we've got 32. And since it's just a single decimal place, we can think of that as like 12 over 10 because it's just in the tens place. And then I can reduce that. So that would be negative 6/5. And then since the power is negative, I would want to put that into the denominator and then make the power positive. So I'd have 1 over 32 to the 6/5. And so what that's telling me to do is it's telling me to 5th root, here, I'll write it down here. It's telling me to 5th root my 32, my base of 32, and then take that and raise it to the power of 6. Or it's saying to take 6 of the 5 factors that multiply together to be 32. Well, the 5 factors that multiply together to be 32 is 2, right? 2 times 2 times 2 times 2 times 2, 5 times is 32, and I just need to have 6 of those. So we're going to think of this as 1 over 2 to the 6th power. So I just need to multiply by 1 more 2. And now I have 6 of the 5 factors that make up 32. So then that would be 64, or 1 over 64 in this case. And so that would be our answer for this one. Now in this one, we're going to combine a lot of different things. We got radicals, we got rational exponents, we have properties here. So in this case, because these items are connected by multiplication, I can go ahead and distribute the exponent to all of them. So I'm going to have 9 raised to the power of 3/2. I'm going to have y raised to the power of 3/2. And then my square root of x, I'm going to rewrite that as x to the 1/2. And then that is also being raised to the 3/2. So the 9 to the 3/2, that would actually just be the square root of 9 cubed, if you will. And then I'll just leave this as y to the 3/2. And then here I'll use the property where I just multiply the powers together. So then I'll have x to the power of 3/4. Well, the 9 to the 3/2, which again, the other way I think about that is 3 of the 2 factors that make up 9. The 2 factors that make up 9 is 3. And this is telling me I need 3 of them. So it's going to be 27. But you could also think of that as square root the 9 to get 3, and then cube the result to get 27. So when all is said and done, I have a 27 times y to the 3/2 times x to the 3/4. And I have finished raising that one to the power of 3/2. And then in this example, again, we're raising all of these different items that are being multiplied together to the same power. So I am allowed to distribute that power as long as these items are connected by multiplication. So I'm going to do, actually, wait, I just noticed something. My exponent is negative, and that negative is applying to the whole product. So actually, before I do what I was about to do, I'm going to put this entire thing in the denominator. Because all of it was being raised to a negative. So I'm going to think of this as 1 over all of this stuff raised to the positive power of 1/3. Then I'll go ahead and distribute that power. So for this, I'm using the property that says if you have a power to a power, you multiply powers. And then for the number, I'll just raise the number to the power. So I have 1 over 27 to the 1/3. And then times x squared, because 6 times 1/3 is 2, and then times y to the 3rd, because 9 times 1/3 is 3. And then the only thing left I have to do is evaluate 27 to the 1/3, which is basically just the cube root of 27, which is basically just 3. So then the final answer for this one would be 1 over 3 times x squared times y cubed. So on your note guide, there's space here for you to fill in, I think, four examples. So looking over the ones we just did, I want you to choose 4 of them and copy them down on your note guide and leave yourself some notes in this area of things that you need to remember. And then I just realized one other thing I wanted to point out is these other do's and don'ts of dealing with exponents. So we already used this property right here. But if you are multiplying different bases together and then that product is raised to the same power, you can and should distribute the power across multiplication. So we just used this property in the last 2 examples, but I want to really, really emphasize you cannot do that if you're adding the different bases or subtracting the different bases. So for example, like if you have x plus 4 squared, that does not and never will equal x squared plus 4 squared. It doesn't work that way. When you have what we call a binomial raised to a power, you would have to just multiply that binomial to itself that many times. And then that would obviously equal like something different. So just remember that. Don't distribute exponents across addition, subtraction, only across multiplication and division. And so if you stick to these rules, you should be good to go with skill 5. You'll notice in Canvas there is a homework assignment attached for skill 5 practice. So I am hoping that you'll have time left over in this block period to work on that. And I left a note for the sub to tell him that you are to finish both the video and the practice assignment. So I will also scan and upload pages of the textbook so you can just view the problems in Canvas and do them on paper. And I will be back in school tomorrow, so feel free to stop by if you have any questions about anything. or reach out to me through email or Remind. Thank you. Bye.